Hey everyone, I just have a quick review on properties of rational exponents today. For the first problem in the upper left, it's the cube root of 32x to the 7th y squared. Just as a reminder, this cube root on the outside, not in black, in yellow, if I can figure this out, that's called the index. So my index here is 3, meaning I want to reduce everything into perfect cubes. The first thing I look to see as well is 32 a perfect cube. If you don't have your perfects card with you, if you left it at school or if you lost it, you can just search Google for list of perfect cubes and they'll come up. If you don't have that handy, or if you don't have internet access, which I guess you wouldn't be able to hear me right now, you should be able to list them out: 1 cubed, 2 cubed, 3 cubed, 4 cubed, so on. 1 cubed is 1, 2 cubed 8, 3 cubed 27, 4 cubed is 64. So as we can see, is 32 falls somewhere between these two numbers, so it's not a perfect cube. So we got to ask ourselves, well, do any perfect cubes multiply in to 32? And you could say, well, yes, 8 times 4 is 32. So I'm going to rewrite this as the cube root of 8 times 4 times x to the 7th y squared. That helps me now because the cube root of 8 is 2. So I could say this is 2 times the cube root of 4. Can't come out at all. Now for my x's, again, this is like the get out of jail thing. So it has 7 tickets. It needs 3 to get out, so I can get out 2 times with 1 left over. And my y's needs 3 tickets to get out. It only has 2, so it stays in. Your final answer would be 2x squared times the cube root of 4xy squared. And this looks kind of goofy because there's this space right in here. So if you want, you could rewrite it as 2x squared times the cube root of 4xy squared. I don't expect it to be like perfect every time. Like, you're going to end up leaving this space sometimes because you don't know how many things you're going to be able to pull out. Okay, on to number 2. Number 2, now we are dividing. Now, remember, when we have just plain numbers, like 54 and 27, we either divide or reduce those. So if I just had 54 over 27, you'd say, well, that doesn't divide out nice, or does it? 54 divided by 27 is just 2. Okay, now for my x's, I have a negative exponent here. If you remember, anything with a negative exponent gets flipped. So this goes to the bottom. Now, a common mistake here would say, well, I put this x to the bottom, so my x squared, that must go to the top, right? Wrong. Only the things with the negative exponents get flipped. So I have an x squared on bottom from before, and now I also have a positive x to the 7th. Okay, now for my y's, I have a y to the 5th on top and a y to the 3rd on bottom. You need to ask yourself, well, which one's bigger, top or bottom? The top is bigger. By how many? 2. And now the last thing we need to do is just simplify the bottom. And again, I have the same base here. This has an x, this has an x. So when we are multiplying exponents with the same base, we simply add the exponents. So this turns into 2y squared over x to the 9th power. That would be your final answer. The key there is, with numbers, we just reduce or divide. With exponents, we add or subtract the exponents after we get rid of the negatives. Okay, I only got 2 more here. Now, number 3, similar to dividing, when we are multiplying exponential functions, what we say is, well, 6 times negative 7, we just multiply those straight across like we normally would. Just what's 6 times negative 7? Negative 42. Now for my exponents, it's x squared, color-coded, x squared times x to the 6th. And again, if I had x squared times x to the 6th, I have the same base, so I simply add my exponents. Negative 42, x to the 8th power. That's it. Okay, last but least, number 4. Number 4 is more or less the same thing. I'm going to multiply my whole numbers. 3 times 4, well, that's 12. Now I'm going to have x squared times x to the negative 7th. Again, same base, add the exponents. I get 12x to the negative fifth power. Now my problem is, well, I can't have a negative exponent. So how do you get rid of a negative exponent? Only the base that has the negative exponent goes to the bottom. So I turn this into a fraction, 12 over, and now this guy goes to the bottom, x to the positive fifth power, 12 over positive x to the fifth. Okay, we are reviewing this today because what we're going to be doing when we start our new content, again, I have no idea when that's going to be, but I'm assuming at some point we'll be doing some online new content, or if we do it face-to-face. Regardless, the next stuff I will be teaching you will use properties like this. So after you've watched this video, I think I am including 8 to 10 problems. They're pretty simple, they're pretty basic, just reviewing these properties. Later in the week, we're going to do the same thing, but it's going to be graphing exponential functions. I'll post a quick video like this and then 5 to 8 problems for you guys to graph. Just a reminder that I want you to submit your work via Google Classroom. Please don't email it to me. It's just kind of not frustrating, but when I have 100 students and each kid emails me pictures of their homework, it just kind of floods my email. So it's not the end of the world, but please, it would make my life a little bit easier if you submit it via Google Classroom. If you don't know how to do that, I posted on a Google Doc how to, or you could email me and I can shoot you a video or something like that.